problems. All right, so we're on this page. We did this one at the top. This is where we stopped yesterday. We're going to finish these last two here, which are really not any different than what we were doing yesterday. The only thing is that they are asking about the multiplicities. And I kind of talked about this a little bit yesterday. And that multiplicities just means if a number shows up more than once, we would state that. Like we would say multiplicity of however many times that answer came about when we were solving it. So this first one, we're going to factor it just like we did yesterday. We're going to group and factor here. We're also going to still think about end behavior because they still want us to sketch the graph. So it might be helpful to think about what is the graph doing for end behavior here. So if you look at this, is it positive or is it negative? Don't all speak at once. Is it positive or is it negative? It's positive. And is it even or odd?
Odd.
It's odd, right? Because of the 3. So we had problems that looked like this yesterday. And I think our bell ringer was this too, right? So this means that it starts on the left by going down. And on the right, it's going to end by going up. Odd is telling you they're going to face opposite directions. Because we know it's positive, that means that the end of the graph or the right side of the graph is going to eventually go up forever. Now let's think about factoring this. If we put parentheses around the first set and the second set, what can we take out of those first 2 terms?
X squared.
And that would leave me with x plus 2. And then what can I take out of my second set?
-4.
Good. And that leaves me again with an x plus 2. Now, if I set these things equal to 0, what do I get for answers for my x?
2 and -2.
So when you do this left one, you square root the 4, right? So it would be positive and -2, correct? And then this one would be just -2. But which answer is showing up twice here?
-2.
The -2. So we talked about this yesterday, but now what we're going to start doing is actually stating what numbers might have multiplicity when they do show up more than once. So I'm going to say x is going to be equal to a positive 2 and then the -2, but right next to it in parentheses to state the fact that it showed up twice. What we're going to do is write multiplicity, and I'm going to abbreviate that, MULT, of 2. You could, yes. But we'll talk more in a little bit too about multiplicity on what does that mean as far as how the graph works. So it still maybe is just good to think about, is the multiplicity an even or an odd number? Because we'll talk about how it acts on the graph then, because it does do certain things. And now what I'm going to do is come over here to my coordinate plane. These x values I can plot. They're going to be on the x-axis because that's what they mean. When you solve for x like that, you're finding where the graph is crossing the x-axis. So we're going to put one at -2, and we're going to put one at +2. And yesterday, we spent some time going on our tables and like looking for more points. I'm not going to be so concerned about doing that right now. Because I do know what my end behavior is, which is the fact that the left side of the graph, so at that -2 spot, it should be going down forever. Like so. And then at the +2, this is when it starts to go up forever. Okay, and then the stuff in the middle, while we could go to our table, we could get some points to really see what it's doing, or I could put this on a graphing calculator or a graphing website. I'm not too concerned about it right now, but I do know that there's probably going to be some movement in there. So I'm just going to connect them by just kind of giving it a little swoop there in the middle to kind of just show what's happening. So the only main difference I'm adding today is that we are going to start stating when roots are repeated by calling it multiplicity. So if we look at the next one here, is this Positive, negative, even, odd. Okay, and so it behaves just like the last one did. It's going to be going down on the left. It's going to be going up on the right. Okay, now we got a factor. So I'm going to put parentheses up here. What do you guys want to take out of those first two terms? Good. And what would be left over? Out of the second set? You want to take out positive 9 or negative 9? Okay, so now we're going to set x squared minus 9 equal to 0 and x plus 3 equal to 0. What do we get for x here?
Plus or minus 3 and negative 3.
Good. So which one's showing up multiple times? Negative 3. So I'm going to write over here x is equal to 3, and then negative 3, again with my multiplicity of 2. And then we can go ahead and graph this one. It's going to look pretty similar to that last one we just did because the end behavior acts the same way. So I'm going to put points at negative 3 and positive 3 on my x-axis. And then I know that the left side should go down forever. And I know that the right side should go up forever. And again, there's going to be some stuff that happens in between those points. Again, I could look at an actual table, a graph, a graphing calculator or something like that to actually see the movement there. But again, I'm not really too concerned about that information currently. I just kind of more just want to see what the end is doing, where those roots are at. All right, go ahead and turn your page